I'm standing on a flat, unremarkable stretch of land in central Texas, where the horizon feels unusually wide, and the ground beneath my boots gives no hint of what lies below. There are no cliffs here, no exposed canyon walls, no dramatic rock faces, just soil, grass, and a surface that looks quiet, settled, and ordinary. And yet, this is exactly the kind of place where geology likes to hide its most revealing stories. What first drew attention to this area wasn't a rock outcrop or a fossil eroding out of a hillside. It was something much subtler, a pattern that didn't belong, a layer that showed up where it shouldn't have, something buried, unseen for millions of years, quietly contradicting the surface narrative of Texas as a land of endless plains and predictable sediments. Texas is often imagined as geologically simple, vast, flat, layered with sediments laid down by ancient seas and rivers. And in many places that picture is mostly true. But geology is never uniform, never as simple as our mental maps suggest. Beneath the surface, this region holds a far more complex history, one shaped by violence, movement, and sudden change. The environment here today is dry, warm, and stable. The soil is thick, masking the bedrock below. Rivers meander lazily, their modern paths shallow and narrow compared to what they once were. Standing here, it's difficult to imagine catastrophe, difficult to imagine energy, difficult to imagine that this land was once shaped by forces capable of tearing it open. But buried beneath this calm surface is evidence that something very different happened here. The first clues came not from dramatic discoveries, but from routine work. Core samples drilled for groundwater studies, subsurface surveys conducted for infrastructure, seismic data collected for energy exploration. Again and again, geologists noticed something unexpected appearing in the data. Layers of rock that didn't match the surrounding sediments, compositions that seemed out of place, textures that suggested rapid emplacement rather than slow accumulation. When samples were brought up, the story became clearer. Beneath meters of soil and sediment lay dense, fine-grained rock, igneous in origin. Not lava flows spread gently across the surface, but rock that had formed underground, cooling slowly enough to crystallize tightly, yet fast enough to preserve sharp internal structures. This alone was surprising. Central Texas is not known for active volcanism in the recent geological past. There are no towering cones, no visible calderas, no obvious lava fields. So why was igneous rock buried here at all? Looking closer at the cores, patterns emerged. These rocks weren't isolated blobs. They formed linear bodies, cutting through surrounding sediments at steep angles. In cross-section, they appeared as walls, vertical or near-vertical sheets of solidified magma that had intruded into the crust and then vanished from view as erosion and deposition buried them. These were dikes. Dikes are geological intrusions, formed when molten rock forces its way into fractures in the Earth's crust. They don't erupt at the surface. Instead, they inject themselves underground, exploiting moments of weakness when the crust is under stress. Once the magma cools, the fracture is permanently filled, leaving behind a rigid record of that moment of failure. Finding a dike is not unusual in volcanic regions. Finding networks of them, deeply buried in what appears to be a stable sedimentary basin, that's something else entirely. At the surface, Texas tells a story of long, slow processes. Ancient seas advancing and retreating. Rivers depositing layer after layer of sand and mud. Coastlines shifting gradually over tens of millions of years. But these dikes cut cleanly through that story. They ignore sedimentary boundaries. They slice across time, arriving suddenly, violently, and without regard for what came before. To understand what they mean, we have to reconstruct a version of Texas that looks nothing like what we see today. Millions of years ago, this region was not quiet. It was under stress. Deep below the surface, the crust was being stretched, heated, and fractured as tectonic forces reshaped the southern margin of North America. The continent was adjusting to distant collisions and separations, responding to forces that acted slowly but relentlessly. As the crust stretched, pressure built up in the mantle and lower crust. Magma formed, not in one massive chamber, but in scattered pockets, accumulating wherever conditions allowed. Over time, that pressure sought release. When the crust finally failed, it didn't fail gently. Fractures opened rapidly, propagating upward and outward through kilometers of rock. In those moments, magma surged into the openings, filling them completely. These intrusions didn't form mountains. They didn't create volcanoes visible from afar, but they were no less catastrophic in geological terms. Each dike represents a sudden injection of energy. The movement of molten rock underground generates earthquakes, alters stress fields, and changes the thermal structure of the crust. Groundwater systems are disrupted. Surface deformation can occur, subtle but widespread. Landscapes tilt. Drainage patterns shift. And then, just as suddenly as it began, the activity stops. The magma cools. The fractures seal. The surface settles. Over time, sediment returns. Rivers deposit sand and silt. Soils form. Vegetation takes hold. The land forgets, but the rock does not. As more data accumulated, it became clear that these dikes were not isolated incidents. They formed swarms, parallel and intersecting intrusions spread across wide areas. Their orientations revealed the direction of stress at the time they formed, pointing to a regional tectonic event rather than a local anomaly. This changes how we understand the history of Texas. Rather than a passive basin quietly collecting sediments, this region experienced episodes of deep instability. Moments when the crust fractured on a large scale. Moments when the earth here was not calm, but actively rearranging itself. The discovery also forces us to rethink the timing of these events. Radiometric dating of the igneous material places their formation during periods of known tectonic reorganization in North America. Times when continents were shifting, ocean basins opening, and stress was transmitted across vast distances. Texas, it turns out, was not isolated from these processes. It was part of them. What makes this discovery particularly striking is how completely it was hidden. Without drilling, without subsurface imaging, these dikes would remain unknown. There is no obvious surface expression, no dramatic outcrop to attract attention. They are buried records, accessible only through careful observation and interpretation. This is a reminder of how incomplete the surface story always is. Geology is not written only in what we can see. Much of it lies below, invisible, waiting for the right tools or the right questions to bring it into focus. Zooming out, discoveries like this resonate far beyond Texas. On other planets, we rely almost entirely on surface expressions to infer subsurface processes. On Mars, for example, linear ridges exposed by erosion are interpreted as ancient dikes, preserved for billions of years in a landscape that no longer actively reshapes itself. Those Martian features tell us that Mars, too, experienced episodes of crustal stress, magma intrusion, and internal reorganization. The same processes that left buried walls beneath Texas once operated on a planet that now appears geologically silent. This parallel is important. It reminds us that planetary geology follows consistent rules. Stress builds, crust fractures, magma moves, landscapes change. Whether on Earth or elsewhere, the record is written in rock. Back here, standing on soil that hides so much history, the discovery feels almost intimate. It's not the scale of Yellowstone or the spectacle of a volcanic arc. It's quieter, subtler, but no less profound. These buried dikes tell us that catastrophe doesn't always announce itself at the surface. Sometimes it unfolds underground, leaving no immediate trace, only to be discovered long after its effects have faded. They also remind us that stability is often an illusion. The land beneath our feet feels solid, permanent. But the geological record tells a different story, one of repeated disruption, of balance lost and regained, of energy released and stored again. As I leave this place, there's nothing to photograph, nothing dramatic to point to, just flat land stretching into the distance. And yet, knowing what lies beneath, it feels transformed. Every step crosses ancient fractures. Every meter passes over frozen magma, injected during moments when the Earth here was anything but calm. Texas, buried and quiet, holds evidence of surprises powerful enough to rewrite its geological identity. And that evidence doesn't ask to be believed. It simply waits, patiently beneath the surface, for someone willing to look deeper.